Hi there and welcome to CodeFramer. Let us continue further to understand the Python memory management and garbage collection concept, with another example in this video. If you have not seen the part 1 video, then I highly recommend you to watch it first, and then come back to this video. You can find the part 1 video link in the description. So let us see how memory management works in Python in case of object-oriented programming with classes and objects. So, let us consider an example, where we have a class for an employee. So we can write, class, employee, and then we can write the constructor of the class, which takes name of the employee as the input, and assigns it to the instance variable, employee name. Let us also create an instance method, which will fetch the name of the employee for us. So we can write, def, getName, and we can simply return the name of the employee. If you are new to Python, then you may get a little uncomfortable with the syntaxes here. But don't worry, just focus on the concept of memory management in this video. Let us move forward. So here, we have our heap memory, and the stack memory. We create an object of the class employee, with the name Mike, so we can write, emp, equals, employee, and in closed brackets, we can pass the name, which is Mike. So when this code is executed, the main stack is created in the stack memory, and inside the main stack, the variable, emp, is created. Then the employee object is created in the heap memory. Along with the creation of employee object in the heap memory, the constructor of the class is immediately executed, which is the init method. Due to this, a new stack is created in the stack memory for the init method execution. This also creates the instance variable in the employee object stored in the heap memory. And then the init method initializes the instance variable by storing the employee name, Mike, in the heap memory. Now the employee object in heap memory is mapped to the self in the stack memory, and the name Mike will be mapped to instance variable, name. This is how the constructor is executed, and once all the objects are created and mapped in stack memory and heap memory, then the init stack will be removed from stack. Now the variable emp in the stack memory will be mapped to the employee object in the heap memory. I hope that this is clear. Now let us invoke the instance method, getEmployee, and see how objects are created and mapped in the memory. For example, if we write, my_name, equals, emp, dot, and then we can give the name of the method, which is, getName. This will invoke the instance method. The moment this line of code is executed in the main stack, my_name variable will be created in the main stack, and a new stack is created over the main stack, for the getName method, in the stack memory. The variable self will be created in the getName stack as the object reference to the employee object, stored in the heap memory. Remember that we are passing this self in the getName method. Using this self reference in the stack memory, which is pointing to the employee object in heap memory, we can point to the instance variable, employee_name, and the value Mike can be accessed. This value will be stored in the my_name variable, in the main stack. Now if we want to print the variable name, my_name, then a new stack for the print function is created in the stack memory, and the value of the my_name variable is passed as an argument. This will print the name for us in the console. Once the print function is executed, then the stack created for the print function is removed from the stack. This is how various objects and its members are created and mapped in the stack memory and heap memory. I hope that this is clear. Now let us understand about the removal of objects happening in an example, so that we can understand how the garbage collector will remove the dead objects from the memory. For example, if we create an object for the employee class, so we can write, emp1, equals, employee, and pass the name as Mike. This will create the emp variable, in the main stack, and it will be pointed to the employee object in the heap memory. If you remember in the last video, we learnt about the object reference counting table, which keeps track of each object and the number of references it has. So in this case, the employee object 1 will have the value of 1, as the number of reference. Now we can write, emp2, equals, emp1. Then emp2 variable will be created in the stack memory, and it will also be mapped to the employee object 1. This will increase the number of reference counts, for employee object 1, to 2 in the table. Now if we write, emp1 equals none, then the mapping between the emp1 variable will be broken from employee object 1 in the heap memory. This will reduce the reference count of the employee 1 object from 2 to 1. Now if we write emp2 equals employee with name John, then a new object will be created in the heap memory, and the variable emp2 will be mapped to the new object in heap memory. This will reduce the reference count of the employee 1 object to 0. The moment reference count goes to 0, for the object employee 1, it will be declared as the dead object. This will immediately invoke the garbage collector, and this object will be cleared from the memory. This is how the garbage collector is invoked based on the reference counting of each object present in the memory. I hope that his concept is clear. Now to deepen your understanding about the basics, let me give you a few examples to show how Python memory management is different from other languages like Java. So in Python, when we write a equals 20, where a is the variable, and 20 is the value stored in the variable. Here, if you notice, no data type declaration was required to store an integer value into the variable, whereas in Java, we will have to declare the data type of the variable before storing an integer value. For example, the same expression in Java will be written like this: int a equals 20. This is because Java is a statically typed language, whereas in case of Python, the interpreter dynamically finds the data type of the value and stores it into the variable. This is why Python is known as a dynamically typed language. I hope that this is clear. Also remember that in this example, in case of Python programming language, the variable a contains the reference to integer object 20, whereas in Java, the variable a will store the actual memory location of the value 20. Now if we add 5 to the variable a, then in Python, the variable a will start pointing to a new integer object in the heap memory, with the value 25. Whereas in Java, a new memory location with the value 25 will get stored in the variable a. Also, when we write an expression, b equals a, then in this case, in Python, both variable a and b will reference to the same integer object 25 in the heap memory, whereas in Java, a and b will have two different memory addresses stored for two different locations in the memory where 25 is stored. I hope that some of these basic differences in memory management of different languages are clear. These concepts will be extremely helpful while solving many problems in the future. As a developer, it is extremely important to write optimized algorithms based on time and memory complexity. Without really understanding how memory management works, it will be impossible for anyone to write memory optimized code. Now you got the basics of memory management. I highly recommend you to read more about this topic to further deepen your understanding. If you like this video, then hit the like button, share it with other code lovers, and subscribe to CodeFramer for more. See you in the next video. Thanks for watching and happy learning.